In this example, we're going to look at multiplying mixed numbers. According to the Bureau of Labor Statistics, the buying power of the dollar is 1 4/5 times larger in 2016 when compared to 1991. Now we want to determine the comparable buying power in 2016 of $10 in 1991. Okay. So let's start by drawing a picture. So in 1991, we want to see we have $10. So I'm just going to draw a little $10 bill. And we want to see what this corresponds to in 2016. Okay, so they say it's 1 4/5 times larger in 2016. So we want 1 4/5 copies of $10. So here's my one copy. And this would be $10. And now I want 4/5 of a copy. So I'm going to take the $10, I'm going to cut it into 5 equal pieces. And we want 4/5. And let's shade in what we have. So here's our 1 and here's our 4/5. Okay. But we need to know what each of these 4/5 is equivalent to. Now, if we take the $10 and divide it into 5 equal pieces, we know that each of the 1/5 is $2. And then 4/5 would be 4 copies of the $2, which is $8. So we have $10 plus $8, which is $18. Okay, so in 2016, the buying power of $10 from 1991 is equivalent to $18 in 2016. So we took 1 4/5 of a copy of $10. So now let's write this out in the algorithm. So we have 1 4/5 times 10. Okay, and this is a new situation for us. We're multiplying a mixed number by a whole number. Now notice in the picture, and recall that 1 4/5 really means 1 plus 4/5. Okay, we can't just multiply the 1 by the 10. Okay, notice that that would give us 10. Okay, and we don't have 4/5 by itself. We have 4/5 of 10. Okay, so we can multiply the 1 by the 10 and get 10, the 4/5 by the 10, and that would give us 8 to give us the total. But that would be a lot of computations. So instead, what we do is we'll rewrite this mixed number as an improper fraction, so 9/5 times 10. And now we don't have to worry about that addition in between. We can just multiply across. So we have 9 times 10 over 5. I'm going to cancel out the factor of 5. This cancels to 1. This cancels to 2. And we get the result of 18, which corresponds with our picture. Let's look at the next one. Javon bought a rectangular piece of land in Alaska. The land was 2 3/4 miles wide and 3 5/8 miles long. And we want to know how many square miles of land did he buy. So we're going to make a really rough sketch of this, or else it'll get really ugly. But I just want to connect this idea to the fractions we saw before. So I'm going to write 3 here and 4 here. So I'm just making it a little bit bigger than the 2 3/4 and a little bit bigger than the 3 5/8. Okay, so now we're going to have whole numbers for part of it. Cut this into 4 pieces. Okay, and now I'm just going to make an estimate shade. Okay, 2 3/4 would be about to here-ish. Okay, and 3 5/8 would be 1, 2, 3, and a little bit more than half. Okay, so this is approximately the size of the piece of land he bought. Okay. Now we can see there are 1, 2, 3, 4, 5, 6 full square miles. Okay, and here are some partial ones. So this was 3/4. This little piece for 2 3/4. So that's 1, 2, 3/4. So these are 3/4. Okay, these here, this was 5/8 by 1, so these would be 5/8. And this little piece would be 3/4 by 5/8, which is 15/32. I'm just multiplying them, and we could add all of these up, but I don't want to do that either. Instead, we're going to see how this connects to the symbolic representation. Okay, notice this is less than 12 square miles, and I would guess about 10-ish based on what's missing outside of here. But we are finding 2 3/4 copies of 3 5/8. And we're going to rewrite this using mixed numbers, so 11/4 times 29/8. Now 11 times 29 is 319, and the denominator, 4 times 8 is 32. And notice this is really close to 10. If this was 320, it would be 10 times as large as 32. So that means it's 9 and 31/32 square miles. Okay? And you could check that on your calculator to see how it corresponds. I know I did it very quickly. But it's less than 12. It's more than 9. Okay? And we use the same process that we used when we found the area before. We just transformed them into improper fractions, so we didn't have to multiply all the different pieces because they're mixed numbers.